mechanical properties of solids. And we are discussing application problems on Young's modulus. Let us discuss. Next question. A copper wire of length, ध्यान से सुनना, how this problem is tackled. And a steel wire. Now start visualizing what the question says. A steel wire of length 1.6 meter, both of diameter 3.0 mm, are connected end to end. The net elongation is found to be 0.70 mm. Obtain the load applied. Now this is a problem which requires a composite type of material. There are two materials separately. One is copper, another one is steel, and they have been joined together as a single wire. If you read the question very carefully. So what are the challenges that we have attached to this? How would you visualize such a problem? You have a wire like this, and you have another wire. Let us say, we can say that another wire is shown with separate color. So this is one wire, ऊपर वाला. Let's say this, we show it with green color. And ऊपर वाले वायर को हम क्या कहें? सबसे पहले तो कॉपर ही लिखा है ना क्वेश्चन में, कॉपर लिखा है, तो हम क्या देते हैं इसको C, कॉपर, एंड नीचे वाले को क्या देते हैं स्टील, S, with a common dia. Correct? Yes or no? Tell me. Now suppose it has a common, obtain the load. लोड बोला है ना. Let us say यहाँ पे कॉमन लोड लगाया हुआ है, इसी पे ही एक कॉमन लोड लगाया हुआ है, कितना W, राइट. और इसका जो एरिया है, ऑब्वियसली क्रॉस सेक्शनल एरिया कितना लेंगे हम, A ले लेते हैं. क्रॉस सेक्शनल एरिया इज A. Okay. So if we see what is the formula, फंडामेंटल फॉर्मूला, यहाँ पे लिख दो सॉल्यूशन. तो फंडामेंटल फॉर्मूला क्या होता है यंग्स मॉड्यूलस का? y is f upon a, yes or no, और f is here some w, yes. So क्या लिखोगे, w upon a divided by delta l upon l, यही होगा ना. So I would say y of copper would be this, and यहाँ पे a would, w and a तो दोनों के लिए सेम ही है, l को lc लिख दो and l को भी lc लिख दो. दोनों में इलोंगेशन अलग अलग होगा डिपेंडिंग ऑन YC and Y steel. Y steel will be W upon A upon delta LS upon LS. Making some sense or not? If you see, इस रिलेशन से मेरा W upon A क्या आ जाएगा? It will be YC times delta LC upon LC. एंड दूसरे वाले रिलेशन से क्या आएगा? YS times delta LS upon LS. Correct? Yes or no? What are the facts that you have? L of C is given 2.2 meter and L of S is given as 1.6 meter. ये दिया हुआ है तुम. ओके. और इनके करस्पॉन्डिंग YC कॉपर का कितना है? ये आप टेबल से ले लीजिए. 1.1 इंटू 10 टू द पावर 11 न्यूटन पर मीटर स्क्वायर. एंड YS लिख लीजिए, स्टील का होता है 2 इंटू 10 टू द पावर 11 न्यूटन पर मीटर स्क्वायर. कॉपर एंड स्टील. हाँ, मिलेंगे यार, कोई प्रॉब्लम नहीं. सारे कांस्टेंट्स दे विल बी मेड अवेलेबिलिटी. ओके. Now, if you really see, can we put all these values? LC पता है, LS पता है, YC पता है, YS पता है. तो यहां से तुम्हारा वैल्यू क्या आ जाएगा? डेल्टा LC अपॉन डेल्टा LS. ये क्या हो जाएगा? ये हो जाएगा YS अपॉन YC इंटू LC अपॉन LS. यस और नो? और ये वैल्यूज रख दो. YS क्या है? 2 इंटू 10 टू द पावर 11 अपॉन 1.1 इंटू 10 टू द पावर 11 टाइम्स L ऑफ C कितना है? 2.2 अपॉन 1.6. आर यू इन एग्रीमेंट विद मी? ओके. सो यहाँ ये से काट दीजिए, ये कट जाएगा और ये 0.8 आ जाएगा और ये 1.1 आ जाएगा. ऑल राइट. एंड 1.1 से ये कट गया. ऑल राइट. एंड 2 चौका 8 और 2 एकन 2, तो ये आ गया 2.5. करेक्ट? यस और नो? सो जो रेशियो है वो 2.5 आ गया हमारा रेशियो. ठीक है कि नहीं? ये क्लियर हुआ या नहीं हुआ? बोलो. और टोटल इलोंगेशन कितना दिया हुआ है क्वेश्चन में? क्वेश्चन में टोटल इलोंगेशन हमको दिया है 0.70 है. ओके. सो अकॉर्डिंग टू क्वेश्चन लेट अस राइट डाउन ATQ डेल्टा LC प्लस डेल्टा LS इज इक्वल टू 0.70 millimeter. All right. So this is what we have. And at the same time, दूसरा डेल्टा LC upon डेल्टा LS is 2.5. Now from this we can easily get delta LC and delta LS separately. Okay. How? Delta LC can be 2.5 times delta LS. And यहाँ पे हमें क्या मिलेगा? 2.5 times delta LS plus delta LS equal to 0.70 mm. Therefore 3.5 delta LS would be 0.70 mm. So we will get LS, delta LS की वैल्यू क्या हो जाएगी? 0.70 upon 3.5. ओके. सो ये हो गया आपका 0.70 अपॉन 3.5 मल्टीप्लाइड बाई 10 मल्टीप्लाइड बाई 100. सो ये 35 दूनी 70. सो ये हो गया तुम्हारा 20 अपॉन 100 which is 1 upon 5. So 0.2 mm. Correct? Yes or no? यहाँ ये क्लियर है या नहीं है? आप इसको लिख सकते हैं 2 इंटू 10 टू द पावर -4 मीटर ऑल्सो आपका अलग अलग कितना निकल आया? डेल्टा एल सी कितना हो जाएगा? सो 0.5. सो दूसरे वाला हो जाएगा आपका 5 टाइम्स 10 to the power -4 meter. So these are your values. Okay.
So ये 10 to the power -4 क्यों है? 10 to the power -3 होगा.
0.2 है ना? Into 10. 0.2 into 10 to the power -3 meter. So you will say 2 by 10 into 10 to the power -3. You will say 2 into 10 to the power -1 into 10 to the power -3.
I got that, but I'm saying कि 5 into 10 to the power 3 होगा, -3 होगा, so that 10 to the power -4.
Why would that be? Will it not be 1 by 5? ये सामने देखो.
Okay. Sorry.
So that way you can easily get your W. So W will be 8 times YC times delta LC upon L. यहाँ से आप निकाल पाएंगे पाई टाइम्स आपका रेडियस क्या था 1.5 टाइम्स 10 टू द पावर -3 का स्क्वायर पाई आर स्क्वायर हो गया मल्टीप्लाइड बाई 5 टाइम्स 10 टू द पावर -4 टाइम्स 1.1 इंटू 10 टू द पावर 11. सो ये सारा पैरामीटर हमने इसमें लिख दिया एंड डिवाइडेड बाई एल से डिवाइड कर दो. सो एल हो जाएगा 2.2. सो ये फाइनली आपका 1.8 इंटू 10 टू द पावर 2 न्यूटन ये आपका लोड की वैल्यू आ गई. अप्लाइड जो लोड था वो ऐसे. दिस क्वेश्चन इज यूजुअली may come in exam, so it's an important question. I am giving you one question for homework. Do it as homework. In a human pyramid in a circus, the entire weight of balanced group, the entire weight of the balanced group is supported by legs of a performer. Each supported by the legs of a performer. Okay. Who is lying on his back? Who is lying on his back? The combined mass of all persons performing the act and the tables, flakes, etc. Involved is 280 kg. Involved is 280 kilogram. The mass of performer lying on his back. The mass of performer lying on his back at the bottom of the pyramid. At the bottom of the pyramid. Bottom of the pyramid is 60 kilogram. Is 60 kilogram. Each thigh bone. Each thigh bone. Each thigh bone of this performer has a length of this performer has a length of 50 centimeter and an effective radius of 2.0 centimeter. Okay. Determine the amount by which each thigh bone gets compressed. Which each thigh bone gets compressed under the extra load. This you can do at home. Okay. Apply the principles which you have already been taught. Let us now discuss shear modulus. Our topic is shear modulus. If you see what is shear modulus, I had already explained earlier. Let us say that we have got such a structure and I apply the force here. We call it tangential force F, and as a result there is some kind of this deviation. Let us say this deviation is delta x. Okay, and this is your length L. All right. So what we describe here is that the force that is acting is tangentially. Therefore, it will produce the shearing stress. So, shearing stress and the ratio of shearing stress with regards to shearing strain, shearing strain is what is known as modulus of rigidity. Modulus of, we call it rigidity. Rigidity. This is similar to what we just did as Young's modulus. So modulus of rigidity is known as G, and we would call it F upon A, okay, divided by delta X upon L. F upon A is shearing stress, and delta X upon L is shearing strain. So we can also call it F upon A, and then delta X upon A is tan theta, if you remember, tan theta. Now for small angles, I told you tan theta tends towards theta, becomes theta. So it is F upon A upon theta, or we can say F upon A theta. Okay. And F upon A क्या होता है? Sigma S, okay, upon theta. Sigma S क्या है? What is sigma S? Any idea? बता सकते हैं कोई? It is shearing stress. Shearing stress. If you remember, F upon A, that is what was known as sigma S. So we write it like this. So sigma S is nothing but capital G times theta. So remember this as a formula. Let us do one application question here also. A square lead slab, a square lead slab of side 50 centimeter and thickness 10 centimeter and thickness 10 centimeter is subject to a shearing force, is subject to a shearing force of how much? 9 into 10 to the power 4 Newton. The lower edge is riveted. The lower edge is riveted. Riveted माने fix कर देना. Okay. R-I-V-E-T-E-D. Riveted to the floor. To the floor. Okay. How much will the upper edge be displaced? How much will the upper edge be displaced? मैंने क्या पूछा है आपसे? Do you know what is asked? 50 centimeter and thickness 10 centimeter is subject to a shearing force of 9 into 10 to the power 4 Newton. Okay. A lower edge is riveted. So let us, what is my area? Let us answer. So area would be what? 50 centimeter multiplied by 10 centimeter. Yes or no? We can write 0.5 meter multiplied by 0.1. So it is 0.05 meter square. That is my area. Okay. Now the stress will be how much? Shearing stress. Would be F upon A, right? So F upon A means 9.4 into 10 to the power 4 divided by 0.05 meter square, or यहाँ Newton. Alright, so it is 1.80 into 10 to the power 6 Newton per meter square. So shearing stress निकल आया.
So if it force to 9 into 10 to the
एंड
9.42 लिखा है.
एक मिनट 9.0 था ना. ओके लेट्स राइट डाउन. इट्स अ मिस्टेक. सो 0 लिख लीजिए यहाँ पे. ओके सो हाउ मच यू गेट. 5 एकन 5 5 8 40. ठीक है. ओके इट वाज जस्ट अ प्रिंटिंग मिस्टेक. सो शेयरिंग स्ट्रेस हमारा निकल आया. So shearing strain. Now let us identify what is shearing strain. Shearing strain. Okay, it is delta x upon L, right? Which is same as stress upon capital G. Okay, so delta x would be what? Stress delta x would be stress times L upon G. Let's put the values. So it would be stress की वैल्यू कितनी थी 1.8 into 10 to the power 6 multiplied by length was 0.5 mm or sorry meter and then okay then G की वैल्यू कितनी है. G की वैल्यू है 5.6 into 10 to the power 9. Okay so it is 1.6 into 10 to the power minus 4 meter or 0.16 millimeter. ओके सो डेल्टा एक्स जो है हमारा ये निकल आया. सो दिस इज द आंसर. ओके
5.6 into 10 to the power 9 कहाँ से आया?
दिस इज अ कांस्टेंट स्टैंडर्ड कांस्टेंट शेयरिंग स्ट्रेंथ ऑफ द मटेरियल. यस ओके यू विल गेट दैट. It will be provided to you. Okay now in next class we will discuss what is bulk modulus. We'll also do some questions, also discuss Poisson's ratio and application part, and in the next class we will close this chapter.